All right, we're going to look at simplifying rational expressions. Remember, rational in math means that you're dealing with things that can be represented as a fraction. So we're dealing with fractional expressions. You have two rules to start with. If it is possible for you to factor, always factor first. If you don't factor first, yeah, it's not going to be good. The only way these works is if you factor. Because for you to reduce, you have to have things multiplied. Like if you were going to do 8 divided by 6, well, what that really is 2 times 2 times 2 over 2 times 3. And that allows you to cancel out the 2's, so you end up with 4 on top and 3 on bottom. But it's the factors that reduce. It has to be multiplying before you can do it. The other thing is when you get ready to reduce, you are finding a matching pair, one factor from the numerator and one factor from the denominator. When you reduce, make sure that you're not thinking that they go to 0. They're really reducing down to 1. So it is possible for everything to reduce. If everything goes out, 1 is your answer. It's kind of like saying 4 over 4. That's not 0. That's going to be a 1. All right, let's get started. To start with, you're going to have a few that are monomials. So there's no factoring here. You're just dealing with each individual little element there. So start off looking at your coefficients. See if there's something in common. Well, yes, 3 goes into 3 one time. 3 goes into 12 4 times. And then your C's, if it's a variable, guys, all you're doing is subtracting your exponents, and you're putting the remainder or your leftovers wherever the larger exponent was. So 2 minus 1 is 1, so you have 1 C in the bottom. You need the 1 in the top, and you need the 4 in the bottom, just the way they are. Remember, if everything goes out in the top, you have to put a 1 as a placeholder. It has to stand up there and tell the world that everything cancels out in the top. So there's a big difference between 1 over 4C and just 4C. If you just put 4C, that's wrong. It has to be 1 over 4C. So here's another practice problem, 4 and 28. Well, 4 goes into 4 once, 4 goes into 28 7 times. And then you're reducing your variables the exact same way you did before. Well, subtract them, you get 1. Well, the larger exponent was in the bottom, so that's where you put your leftovers. There you go, they're completely reduced. Now let's upgrade. Now we've got binomials. You have to remember all of your methods for factoring, pulling out something common, difference of 2 squares, dealing with trinomials, the easy and the hard kind. I have videos for those too. If you forgot how to factor, you need to look them up and watch them. But remember our rule, always factor first. So, this binomial in the top, what's common? Well, looks like 3. 3 goes into 6 2 times. Still has an A. 3 goes into 9 3 times. You couldn't pull out an A because 9 didn't have one. And then you just got the little 12 in the bottom. Now, you need to understand, if you've got a binomial, anything with a plus or a minus, that is like super glue. All right? You cannot break that up. So this is completely stuck together. You either reduce the whole binomial or you don't touch that binomial. So the only thing available to reduce is the 3 on the outside and the 12 down here. But they do have something in common. 3 goes into 3 once, 3 goes into 12 4 times. So clean it up. You have your binomial that's glued together, and then you have a 4 in the bottom. Now the question is, can you reduce the 2 and the 4? Trick question. I told you that this binomial is glued together, so that 2 is not available to reduce. You are stuck. This is your answer. Don't try to pull out anything from that binomial. Okay, when you come over here to this next practice problem, it's a little different. It's got a trick in it that you need to make note of. 24 minus, that's supposed to be 2p. The only thing common is a 2. Okay, that gives me 12 minus p. All I did was divide my numbers by 2. Now come down to the bottom, you got 4 and 48. Well, 4 is common. 4 divided by 4 is 1. 48 divided by 4 is 12. Now, do you see what I see? Look at your binomials. Oh, so similar, but they're not perfect, right? There's a trick. You can reduce them. think of it like this. If I had p minus 12 and I distributed a negative through there, don't you get negative p plus 12? Now spin that little booger around. Don't you get 12 minus p? So the only thing that's different between the top one and the bottom one is a negative. So you can reduce. You just have to pick up a negative when you do it. So I can do this as long as I put a negative out there. And then I can reduce my 2 and my 4. So clean it up. I've got my negative. There's nothing left in the top, so I've got to put a 1. And the only thing in the bottom is a 2. Okay, let's get a little bit more in depth. Throw in some variety for factoring. There's nothing common in the top, and it's not the difference of 2 squares because it's a trinomial. So think of your trinomial rules. There's a 1 here, so it's the easy version. What 2 numbers multiply to 6 and add to 5? That would be 2 and 3. Signs are the same, both of them positive. So I need 2 pluses. Now look in the bottom. Is there anything common? No. It's a binomial, it's subtraction, and you can do the square root of both of those. So that would be the difference of 2 squares. Square root of the fronts is y, square root of 4 is 2, and the signs are always different. Now's the fun part. Once you get it factored, it's time to reduce. Find your match. It's just like playing the matching game when you're a kid. You got to have 1 up top and 1 in the bottom. You are stuck with y plus 3 over y minus 2. Question. Can you reduce the y's? No, you can't, because those are part of binomials. And remember that plus sign and that minus sign? That's super glue. You are stuck with y plus 3 and y minus 2. If you can't reduce the entire thing, you can't reduce any of it. All right, now this is the hardest level, and I know some of you are probably groaning when you see this one, but we need to think about it. Look up top. You got a 4, a 20, and a 25. Can you take out anything common? Not with the numbers. And when you start looking at letters, the last guy doesn't have an A, and the first guy does not have a B. So there is nothing common here. Since we have a coefficient other than 1, this is the tough kind. But let's just look. This looks like a perfect square trinomial. The square root of 4 is 2, and the square root of 25 is 5. Now he's got a b squared, so just put a b on the back end. That takes care of that. And check it out. 5 times 2, right here, that's 10, right? And don't you get another 10 with the first 2 and the last 5? That's what gives us our 20. So signs are the same. Both of them are negative. So we got that part done. Now scoot down to the bottom. Same thing. You can't take out anything common. No numbers, no letters, so you have to factor the good old-fashioned way. There's nothing special about this one. What 2 numbers multiply to 2? That would be 2 and 1. It doesn't really matter which way you put them, just get them down there. Now, what 2 numbers do you want to use to multiply to 15? And keep in mind, when you put them in here, our middle terms right here, they have to subtract to 1. So I would say let's put a 3 here and a 5 there. That gives me 5a. That gives me 6a. And I need some b's, don't I? Let me put those b's back there. Okay, that right there subtracts to 1, so we've got it. We just have to remember to get the signs right. This says the signs are different. The big pair is positive. 6a is larger. 3 helped make it, so he gets the plus, and there's the minus. Okay, once you get it factored, look for your matches. You got a 2a minus 5 over a 2a minus 5 with the b's. So the only thing that's left is 2a minus 5b over a plus 3b. Can you reduce the a's and the b's? No, because they're part of those binomials, and that right, all of that stuff is glued together. 2a minus 5b is all glued, and a plus 3b is all glued together. This is your final answer. That's as simple as it goes. All right, good luck.